Hey, I'm Briggs Benson, and welcome to the first episode of the new series I'm doing called The Geek Behind Peak Performance, where I take complex physics concepts related to the baseball and golf swings and break them down into plain English using an iPad, some terrible illustrations, and some better explanations, all in 60 seconds or less. This week's concept is related to the kinematic sequence and additive and relative velocities. So if you've been on F23 Torque social media, you've seen this chart before. This is the kinematic sequence chart for the golf swing. And all this shows is the rotational velocity of each segment of the swing from your pelvis to your torso to your leading arm to the club or bat. As you can see, as you climb up the kinetic chain, the total velocity increases. This is because each step in the chain builds off of the one below it. So the faster the piece of the chain below it moves, the faster the next part is allowed to move. And this is the kinematic sequence. Now this chart is a good segue into the difference between absolute and relative velocity. So as you can see, that the height of this blue line is the absolute velocity of the torso with respect to a stationary object, in this case the ground. The height of the green line is the absolute velocity of the torso with respect to zero, or the ground. The difference between these two is the relative velocity of the leading arm and the torso. Since they're both moving at the same time in the same direction, from the point of view of the torso, the leading arm is only moving this fast. So obviously, the goal is to increase the velocity at impact at the final end of the kinetic chain. To do that, that absolute velocity is a function of the relative velocities of all the different parts of the chain below it. Now let me give you an example. Say you're mad at your friend, so you decide to make a bet. You'll give him $25 if he lets you hit him in the face with a pie as hard as you can. He thinks, well, that's easy, $25. This guy doesn't throw that hard, but he doesn't know the power of relative velocities. So what he thinks is about to happen is scenario one. Say you throw the pie 20 miles an hour. He thinks he's going to get hit in the face with a pie at 20 miles an hour. But because you're really mad at your friend, you're going to take advantage of this. You take it one step further. You hop on a moving car. Say the car is driving 100 miles an hour. You can throw it 20 miles an hour. He gets hit in the face with a pie at 120 miles an hour. Starting to look like a bad bet. But you're really mad at this guy, so you're going to take it one step further. Now you throw him on a car. In this scenario, your car is going 100 miles an hour. His car is going 100 miles an hour, and you can throw it 20 miles an hour. So now, when you throw the pie and hit him, he gets hit with a pie at 220 miles per hour. Real bad bet. Take the same anger you have towards your friend and apply it to the golf ball or the baseball. To increase the velocity of this pie, you can increase the speed of the red car, you can increase the speed of the blue car, or you can learn how to throw the pie faster. And notice, this wouldn't have the same effect if the cars were going in the same direction. You'd still only hit them at 20 miles an hour. You need not only the segments to work harder and faster, you need them operating in the correct direction or sequence. Now back to our chart. If you swing stiff as a board and there's no separation in any parts of your body, you're going to hit the ball with the velocity of just a red line. You threw the pie without utilizing any cars. Now say you create some separation in your hips and your torso. That's whenever you hopped on one car and you threw the pie at your friend. Then you're hitting the ball with the velocity of, say, the blue line. Now, when you hop on a car and you throw your friend on the car and you build up your arm strength, now you're at the top of the gold line and you have the maximum velocity where it matters most, at impact. This is why kinematic sequence is so important in rotational sports and why not only the strength of each segment matters, but the sequencing in which they fire matter. Thanks for letting me express my inner geek this week. Now go put these principles into action.